your lead coefficient, your constant, and your degree. Lead coefficient. So on the x cubed, what do you have? All right. Constant, what do you have? -24. And degree, we have 3. So our lead coefficient and our constant we're going to use in the rational root theorem. The degree being 3 is just going to be a way for us to check. We should end up with 3 zeros and 3 factors at the end of this process. Okay, so step 1. What are you going to do? List possible rational roots. List possible rational roots. It is based off of plus or minus P over Q. What does P represent? Factors of the constant. About the Q. Factors of the lead coefficient. So, plus or minus, what are factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. Alright, so let's write our list. Are there any doubles that we need to cross off? No, alright. Factors of the lead coefficient, 1, so each of those terms needs to divide by 1, so obviously that's easy to do. So here's our list. Plus and minus 1, or positive, negative 2, positive and negative 3, positive and negative 4, positive and negative 6, positive and negative 8, positive and negative 12, positive and negative 24. First step, done. Check it off the list. Step 2, what do we need to do with that list? We need to test them. What are we going to test them with? Synthetic division. So test with synthetic division. How do you know when you test with synthetic division if the term or the value that you used is actually a 0? What does it need to end with? With a 0, right? You're looking for a 0, so you want it to end in a 0. Kind of a coincidence, but it's what it's designed to do, right? So, we want the remainder must be 0. That's what we're looking for. Okay, so what's hard is trying to decide which ones to test. So I want you to test positive 1 and negative 1. So take a moment, test those real quick. Synthetic division. And see if either of those give you a 0. Unfortunately, they're both a no. So you should have ended up with a remainder on both of those. Okay, so what do? Right, if the first number doesn't work, does that mean the second number won't? No, it actually means you need to test the next number. So let's test our 2's. So let's test them, and I'm going to test 2 with you. Positive 2. Negative 2. All right, so we have, let's look at our coefficients of our original equation. We have 1, positive 1, negative 14, negative 24. So 1, positive 1, negative 14, negative 24. So we're going to bring down that 1. Hold on, buddy. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 14 plus 6 is negative 8. 2 times negative 8 is negative 16. And that gets me negative 40. Is that a 0? No. All right, let's test negative 2. Bring down your 1. Negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is positive 2. Negative 14 plus 2, you should get negative 12. What is negative 2 times negative 12? 24. What do you end in a? 0. Woo! And you celebrate because you found one. So, this is our x value. So, when x equals negative 2, what factor do you have? X plus 2. Okay, like I said before, once you find 1, 0, you do not keep going until you do step 3. What is step 3? Rewrite in factored form. Alright, so we need to use our information to rewrite our factored form. So, like we said, since x equaling negative 2 is a 0, our factor is x plus 2. And now we need to use our synthetic answer. So our synthetic quotient, what does it become? Right, it becomes, so well, let's see, we have 1, negative 1, negative 12. How do we rewrite that? 1x squared minus 1x minus 12. All right, so now let's write that. So we have x plus 2 times x squared minus 1x minus 12. Now we're done, right? Yay! No, there's a step 4. Remember, 4 steps. 4 steps. What's step 4? It's a rhyme. Step 4, cannot factor more. So step 4, can I factor more? So look at what you have. You have a quadratic. You have x squared minus 1x minus 12. Can you factor that? Are there two values that add to negative 1 and multiply to negative 12? There are. So we have our x plus 2. And what should you factor that quadratic into? X minus 4 times x plus 3. If that equals 0, then what are your zeros? X can equal negative 2. What else? Positive 4 and negative 3. What was the degree of our original polynomial? Oh, the degree was 3. How many zeros did you end with? 3. It's not a coincidence. There's a whole name and theorem for it that we'll go through later. But if you start seeing that pattern now, it will help you out later on. Hey, step 4 process. There's the easy ones. Take a breath, relax, because the next ones that we're going to do are longer and add a little bit more complexity to it. So hopefully you are doing good so far.